Good day, everyone. I will be presenting to you Geographic Information System as a tool for analysis. Now you might ask, what is GIS and what is GIS science? Here are some basic concepts about GIS. Number one, mapping is key but is not the whole story. A GIS or Geographic Information System is not simply for making maps at different scales, projections, or colors. And it's not simply for storing maps or images. In fact, it stores data from which these are created. It is an analysis tool. For every piece of data, it specifies what it is, where it is, how it relates to other pieces of data. They have things in common. See spatial relationship or create new relationships. Geographic Information System is a container of data. It is a container of maps. It is an inventory of geographically distributed features and facilities. It is a computerized tool to automate time-consuming tasks. It is an analysis tool for solving geographic problems. It is a spatial decision support system and a method for revealing patterns and processes in geographic information. It is an organized collection of software, hardware, network, data, people, and procedures, as seen in the image. Now, there are major questions for a GIS. What exists at a certain location? Where are certain conditions satisfied? What has changed in a place over time? What spatial patterns exist? And what if these conditions occurred at the place, like modeling or for hypothesis testing? For example, toxic substance locations, District 24, District 16, or 14 George Boulevard. Proposed school locations, 124 Elm Street and 35 White Road. Now, as seen in the image, the toxic substances, the school locations are exactly mapped out in the using Geographic Information System software. You can see the exact data, or you can locate the exact location of the school. How it looks, form or pattern, how it works, the process involved. Knowledge about process, more valuable than form because can be used to predict. GIS combine general specific knowledge in software and specific information in databases. As you can see in the image, it is just an example of how things are located geographically, because once you tag a specific location, you can classify, you can put notation, you can put any data you want for that particular geotag location. I'm sure you have been using Waze, you have been using OpenStreetMap and other softwares using in your mobile phones. Basically, they came from a Geographic Information System. Now, here are the major questions for you. How much data do I need and of what quality? How can I combine my data to answer my questions? Now, the process of GIS, it thinks about a place or a topic. Ask a question about it. What are the attributes for that particular place or topic? Then you analyze the data to make a map, explore the patterns that appear, enhance the data or modify the analysis as needed. Then ask a new question and then repeat. It's just a simple process, but it takes time and planning. Now, in defining GIS, different definitions of GIS have evolved in different areas and disciplines. Map coordinates, database of spatial or often non-spatial, computer-based link between them. All GIS definitions recognize the spatial data are unique because they are linked to maps. Spatial or geospatial or geographic data. It contains latitude or longitude, street address, X and Y coordinates, range and township, location shown on a map. For non-spatial data, we call this the attributes. We have the name, gender, income, SN or student number, for political party, or whatever it is that you need to gather from that particular point. For the attributes in a database, attribute data are stored logically in flat files. Flat files or shape files. For example, matrix of numbers and values is stored in rows and columns like spreadsheet. Basically, we can import or export data from or to Excel file or comma-separated values. The data model, a conceptual description of how spatial data are organized for use in the GIS or by the GIS. GIS have traditionally used either field or object data models. A field data model uses a raster or a grid data structure. Rasters are faster because maps directly onto computer memory structure. It is easy to understand, read, write, and draw. Rasters are faster because natural for scanned or remotely sensed data. Continuous surfaces like topography. Spatial analytical operations are faster and compressions are easier. Rasters tell us what occurs everywhere. For this example, this image below with a black background is an example of a raster data. However, rasters are faster, but vector data or vectors are correcter. Vectors can represent point, line, and area features more accurately, far more efficient than grids, not where everything occurs or continuous phenomena, but what occurs everywhere. Okay? It works well with GPS receivers. Okay? Object or vector feature types. An example of a feature type is a point, a line, an area, and an annotation. For this example, as seen in the legend, the cross is the well, the blue line is the river, and then is the lake. That is an example of an object or vector file. There are three distinguishing characteristics of a GIS versus other systems. Number one, it provides links between points, lines, grids, and their attributes in a database. Number two, provides algorithm for analysis of spatial data. Number three, it is spatially intelligent. Thinks points, lines, areas, grids are actual spots on Earth's surface. Example, switching projection and computing distances. That's why it has been classified as a more precise and accurate way to map a particular space or an area. Okay. For GIS layers, themes, and overlays. Okay. GIS is a multi-billion-dollar business. The annual software revenue topped 1 billion, increasing at approximately 14% yearly. S3 and Intergraph software revenues account for one half of industry total. GIS industry now at $7 billion. Okay. GIS as an approach to science. Geographic information science is research both on and with GIS. The generic issues that surround the use of GIS technology impede its successful implementation or emerge from understanding of its potential capabilities. Many people now use open source GIS, that is QGIS. This is very much, I have used this very many times. I've used this many times, and this is very much helpful when it comes to analysis of geographic locations. And that's all for this presentation. Thank you for listening.